Greetings. Today we are going to present our final year project. Our topic is Inception-based global context attention network for the classification of coffee leaf diseases. Myself, Joel Kennedy, and my teammate Joshua Alfred, guided by Dr. Karthik. These are the content that we are going to present today. Introduction: Coffee is an important commodity in the world trade, second only to oil. The country Brazil stands out to be the world's largest coffee producer and exporter. Problem description: Coffee is a very vital to the economical and the political sphere of developing countries, and the coffee exports of developing countries generate more than 50% of their foreign reserve. In addition, the demand for coffee consumption in the world is increasing rapidly. Unfortunately, coffee plantation productivity and quality are still quite low due to the disease and wrong plantation technique. The leaves of the coffee plant are vulnerable to fungal and pest attacks that can harm their photosynthetic regions, leading to the production of low quality and diseased beans. Problem statement: the goal of our research is to produce an AI-based solution for the automatic detection of coffee leaf disease. That is a deep learning model that can accurately classify 4 common diseases that are seen on the leaves of Arabica coffee species, namely rust, minor, forma, cercospora. Dataset description. In our work, the research was conducted using the Bracol dataset, consists of Brazilian Arabica coffee leaves, and it contained 1,747 images of size 2048 cross 1024 pixels, and it was resized to 256 cross 256. And from the table, you can clearly see the number of image count in each class in the dataset. Data augmentation and techniques applied. Any successful training of convolutional neural network requires a substantial amount of data. So data augmentation techniques was used to improve the generalizability of the neural network by using the existing training data more effectively. And following techniques are applied: vertical horizontal flip, brightness range adjustment, rotation, contrast, saturation was adjusted, and noise of up to 35% was added. After augmentation, it was increased to 10,070 images, with each class containing 2014 images. This is the proposed system architecture. First, data pre-processing was done. Then the data was split into training, validation, and testing. Then data augmentation was done in training and validation data. Then it was passed down to the model. The model consists of 2 inception module, 1 global context block, and 1 multi-head attention block. Proposed system and modules used. The proposed architecture contains a baseline linear CNN, which is incorporated with the following module. Inception module. It is designed to increase the depth and width of the network without increasing the number of parameters, which help us to reduce the overfitting. Global context block is used to provide the network with a global view of the image, and this module carries the advantage brought out by a non-local network and the SC block. Multi-head attention module is used to calculate weights to allocate higher values to the more important areas. Generally, it concentrates the network attention on the more essential parts of the image. Analysis of experiments. First, the baseline CNN was taken and it was trained with the augmented data set for 120 epochs, and this is the accuracy and loss graph that we got. We got an accuracy of around 91%. Then the baseline CNN was incorporated with the Inception module. This is the accuracy and loss graph that we got, and we got an accuracy of around 92.5%. Then the baseline CNN was incorporated with the GC block, and we got an accuracy of around 94%. Then the baseline CNN was incorporated with multi-head attention module, and we got an accuracy of around 93.8%. Implementation results for the proposed system. We used Adam as the optimizer, and the learning rate was set to 0.0001, and weight K of 0.0001 was used, and loss was cross entropy. And the model was trained with the training data set for 120 epochs, and we achieved an accuracy of around 98.36%. And here we can see the testing evaluation metrics, which is used to analyze the model. This is the accuracy and loss graph that we got for the proposed system. This is the confusion matrix and AUC ROC graph for the proposed network.
So this is the summary of the ablation studies conducted in our project. So the baseline CNN achieved a testing accuracy of 91.66. The Inception integrated baseline CNN produced 92.8 testing accuracy. The CNN connected with the GC module produced 94.24, and the CNN connected with the MHA block, which is the multi-head attention block, gave a testing accuracy of 93.89. And our proposed model, which consists of the inception, global context, and multi-head attention blocks integrated to our baseline CNN, produced a testing accuracy of 98.36. The rest of the metrics mentioned above are the precision, recall, F1 score, specificity, score, Cohen-Kappa score, and the AUC scores. And this is a comparison of our proposed network with the other state-of-the-art architectures. Here we can observe that our proposed network contains a lower number of trainable parameters and has produced a good testing accuracy than the other aforementioned models. And this is the performance analysis of the proposed work with recent research works on coffee leaf disease detection, and our proposed network has outperformed other existing works and their performances. And regarding the manuscript, we have submitted the draft to the Ecological Informatics Journal. We have received the first round of comments from the journal. We have revised and we have resubmitted it again to the journal for further evaluation. And regarding the application, let me show you the application. But before that, I would like to present to you the image samples of our Bruckhole dataset. So we have 5 classes: Cercospora, minor, Phoma, and Rust being the diseased ones, and images of healthy leaf samples. So these are the healthy leaf samples in our dataset. And for a diseased one, let me show you the Phoma. So each and every disease has a unique characteristic, has a unique type of infection on the leaf, and the model will gain these characters present on the image, and it would process it to produce the correct output, the correct diagnosis of the coffee leaf disease. So let me show you the web application. The web application is built and using Flask and Python, and this is the front page for our application, which would ask the user to input a leaf image. So let me give an example of a Phoma infected leaf right here. So I'm uploading it, and the model has detected that the leaf is affected with the Phoma disease. Let me give you another example. Let me give a plain image, a healthy image sample. So the model is going to predict that that the class is healthy. So in conclusion, the consumption of coffee is high worldwide, and these diseases and pests that affect the coffee leaves reduce the production of coffee, and so there is a need for an effective AI-based diagnostic system to accurately diagnose the disease and ensure the right treatment given to the appropriate leaf. So our proposed network employs inception modules, a global net context module to gather the global representation of the pixels, and multi-head attention to carry out multiple attention at multiple parts of the image to obtain precise classification. The results were displayed, and the proposed network showed a testing accuracy of 98.36. Thank you very much.